I'm Anil Kumar, and in this video we will learn how from the equation of a derivative we can figure out increasing and decreasing interval for the function. So the question here is, we have two questions in fact. So the first question is, if the derivative of the function is f dash x equals to x plus 3 times x plus 1 times x minus 4, determine the interval where function is increasing. The second part is a different question altogether. If the derivative of the function f dash x is x plus 3 x plus 1 whole square, so that is a change, and x minus 4, determine the interval where the function is increasing, right? So you need to find the increasing interval of the function when equation for the derivative is given to you. So you can pause the video, answer, and then look into my suggestion. So the idea here is increasing interval means, so it is increasing interval for f of x, it means that f dash x should be greater than 0. That is what it means, right? So from the equation we can have intervals and find the answer. Easier way will be we can actually sketch a graph, right? So we have three zeros here. One is at minus 3, the other one is at minus 1, and then at plus 4. And now this is a polynomial with degree 3, so I could, and all are linear zeros, right? So I could graph like this kind of approximately, where the first 0 is at minus 3, second one is at minus 1, third one is at plus 4. Now from this we can easily read the interval when derivative, this is for derivative f dash x, is positive. It is positive in the interval from minus 3 to minus 1, right? And then it's positive after 4. So union 4 to infinity. So that becomes the answer for part 1. Now follow the same strategy and provide me with the answer for part 2. Let us sketch the graph this time again for the same function, which is f dash x. But this f dash x is kind of different. We have now degree 4, do you see? 1, and this is double 0. So what really happens here is that we have 3 x-intercept. One is at, let's say, minus 1. The other one is at, minus 3, minus 1, and at 4. However, the 0 at minus 1 is of order 2, so it will not cross the line. It has to reflect, right? It has to reflect there, turn. That's a turning point. Now, since the leading coefficient is positive, the graph will be right side up, right? So the graph of this function will be kind of like this. So it goes like this, turns, but bounces back, and then turns. You get an idea. So that's the kind of graph which we are going to get for this function because of this thing here, degree 2. So that bounce is because of that. Now here f of x is greater than 0. I should not say greater than 0. F dash x is greater than 0 means f of x is increasing, right? So the answer is, this point is minus 3, that is minus 1, this is 4. So minus infinity, minus infinity to 3 union. So afterwards, after 4 it is positive, right? So 4 to infinity. So these are the intervals when the graph of the function f of x is increasing, correct? So you can appreciate how the degree or the order of x-intercept or order of 0 makes huge difference in our increasing and decreasing interval. I hope you appreciate it. Thank you.